So this math problem is intentionally designed to try to trick you. So be careful, but here is the question. We have this triangle, and of course, this leg of the triangle extends right here. We're looking for this angle right there. And the sides of this triangle is 4 right here. We have 4 times the square root of 3 right here. And this leg of the triangle right there is 8. Okay, so again, you have been warned. Be very, very careful when approaching this problem. But let's see if you have the geometry knowledge and skills to figure this out. And if you have the answer, go ahead and put that into the comment section. I'll show you the correct answer in just 1 second. Then, of course, I'm going to explain exactly what's going on here and how to solve this problem. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And if you need help in mathematics, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to like and subscribe, as that definitely helps me out. Okay, now before I show you the answer here, why would I create a question that is designed to trick you? Well, what we're trying to do here is practice avoiding making mistakes on a lot of important exams. And this kind of comes up in big exams like the SAT or ACT exam, if you're familiar with these. These are college entrance exams. Sometimes you might even see this stuff like in the GED exam. But a lot of standardized tests or big tests that you have to take, whether it's like getting into college or graduate school or whatever the case might be, a lot of these standardized tests, oftentimes from the math section, try to kind of do a little things to deceive you just to see how strong your knowledge of mathematics is. So it's always good to practice these type of things. I'm going to be reinforcing or reminding you, you got to be very careful when it comes to geometry problems, something like this. And of course, I'll explain all of this in just 1 second. But first, let's go ahead and take a look at the answer. What is this angle? Well, the correct answer is 120 degrees. And by the way, I should indicate, feel free to use a calculator to help you out in this problem. But if you got this right, that is fantastic. Matter of fact, I'm going to give you a nice little happy face, an A plus, a 100%, and multiple stars. So you can tell your friends and family that indeed this person, this guy on YouTube, was not able to trick you into what's going on here. And what's going on here, the key to solving this problem is recognizing what type of triangle this is. Because the figure, the way it looks, is not really the way it is. But if you know your geometry, or if you know geometry pretty well, these lengths right here should indicate something very important about this angle right there. Okay, so that is kind of where I'm going with this problem. So when you take a test, okay, and this comes up again on big tests like the SAT, ACT, it doesn't make a difference. If you're taking any exam and there's some sort of geometric figure, you cannot, you have to be very careful with the way the figure looks because sometimes, not all the times, but test makers have been known to purposely deceive you by trying to make the figure look different than it actually is. Now, you might be saying, well, that's not fair. Well, they're trying to make the point, or they're trying to kind of really test your ability to be careful because in mathematics, symbols really are very, very important. So, for example, if I go like this, I call this is line 1, and let me just draw line 2 like this. So if I say line 1 is parallel to line 2, well, if you look at these lines, they don't look parallel, but if I state that they're parallel, well, we have to kind of apply all the properties that we have when it comes to parallel lines. And oftentimes, students or people will look at figures and they'll be like, well, the figure doesn't look like what I think it's supposed to look like. So you got to be super careful. So here's the deal. In order to solve this problem for this angle, we need to figure out what type of triangle this is. And this particular triangle is something called a special right triangle. And if you are a geometry student or maybe studying even algebra, These are triangles that you need to know. There's two types of special right triangles that you need to be able to recognize, whether, again, you're taking geometry or studying algebra or trigonometry. And here are these triangles, okay? So it's the 45, 45, 90 degree special right triangle and the 30, 60, 90 special right triangle. You have to be able to recognize these triangles. Now, I'll tell you more about these type of triangles here in a second. But if you are really, really, let's say, good in terms of recognizing special right triangles, you'll see that this triangle right here actually is a 30, 60, 90 special right triangle. In other words, this figure right here is 90 degrees, but we have to kind of validate that. And if you don't know why this is a 30, 60, 90 degree right triangle, well, that's not going to help you out, right? Because you got to be able to recognize these types of triangles. Okay, so I'm going to do two things here. First of all, let me just quickly talk about a 30, 60, 90 and a 45, 45, 45 as a quick review. But let's suppose you forgot about 30, 60, 90 special right triangles. But let's say you thought, you know what, Mr. YouTube Math Man, I think this might be a right triangle. It doesn't look like a right triangle because this looks like an obtuse triangle. An obtuse angle is one that's more than 90 degrees. But maybe you might say, I think this guy on YouTube, maybe he just didn't, draw this figure accurately, but he did tell me he's trying to trick me. So what we can do is we can always use the Pythagorean theorem to see if this is a right triangle, right? So in other words, this side clearly appears to be the longest side, so that would be our C. So we could plug these two sides in for A and B and just see if this relationship holds true. In other words, the sum of the squares of these two sides, is that equal to the square of the longest side, which of course would be the hypotenuse. Now, if this holds true, this only holds true if this is a 90-degree right triangle, and this really is kind of the key to solving this problem. Now, if this is a 90-degree triangle, and it is, then finding this angle right here, basically, that's a whole, kind of different discussion. So let's just kind of suppose right now, all right, this is a 90-degree angle. Well, again, we still have this problem of figuring out what's the angle over here. Well, there's two approaches to this. If you didn't know about 30, 60, 90 special right triangles, then you would have to know some basic trigonometry to figure this out, some trigonometric ratios. But we can kind of spare ourselves from doing trigonometry if we understand special right triangles. But I'm going to verify the lengths here by using the Pythagorean theorem in just 1 second. But let's just talk about these two special right triangles before we move on, because this is very important stuff. Okay, so the first one is a 45, 45. I'm just sketching this out. So this is a special right triangle. So you can kind of identify this as basically it's like a square where the diagonal runs through. So it's just a right triangle like so. So this side is equal to this side, and then, of course, in geometry, if you have a little line like this, these mean that these sides are congruent. So if this is x, well, then this is x as well. And the hypotenuse here is going to be x times the square root of 2. Okay, so in any special right triangle, that's the deal. So for example, if x is equal to 4, and this is obviously 4, this side would be 4 square root of 2. Now, if you don't believe me, let's go ahead and do this. So real quick, let's just solve for this hypotenuse, and let's have this as 4, this as 4. Okay, so 4 and 4, this is a right triangle. This is, oh, by the way, too, I should stop myself. This is 45 degrees, and this is 45 degrees. These angles are congruent. That's really important. So 45, 45, 90. I apologize for not being clear about this, but this is the properties, again, of a 45, 45, 90 special right triangle. Now, I'm going to verify this way, but why are these angles or why are these triangles so important? Because in trigonometry especially, and of course in geometry, you use these angles, these 30, 60, 90, 45, 45, almost continuously. You have to be, like really, really good with them. So anyways, let's just verify that this holds true. So if this is 4 and this is 4, this should be 4 square root of 2. But let's go ahead and use the Pythagorean theorem to solve this. So it's going to be a squared plus b squared is equal to c squared. So this would be 4 squared plus 4 squared. Is this equal to c squared, or in this case, x squared? We're solving for x. So this would be 16 plus 16 is equal to x squared. This is 32 is equal to x squared. We'll take the square root of both sides, so x will be equal to the square root of 32. And of course, I know that you're up to speed on simplifying radicals. Matter of fact, I'll do this over here. The square root of 32 is equal to the square root of 16 times 2. Okay, so the square root of 16 times the square root of 2. Square root of 16 is 4 square root of 2. And there you go. See, I'm doing this math in real time. I do take a lot of, attention to detail to pre-make a lot of my templates for my videos, but I like to do math in real time as well, just to kind of say, hey, look, I can actually do math. I'm just not writing something down from a book or whatnot. Okay, so you could see that we did solve, use the Pythagorean theorem, that, hey, instead of doing all this work, we could have just simply taken this 4, multiplied by square root of 2, 4 square root of 2, we would have gotten the answer. Okay, so that is the 45, 45, 90. You need to know that for sure. And let's just take a quick look at the 30, 60, 90 special right triangle. Okay, so I'm not going to verify it. Well, yeah, I will verify it actually, but not right now. I'll verify it in just 1 second. But let's just take a look at the properties of a 30, 60, 90 special right triangle. Okay, so here it goes. So right here, the shortest side, what would be the shortest side of this triangle? Okay, well, hopefully you said this, all right, and that would be correct. What is the longest side of this triangle? It's this side, okay? So that's important, and this here we have the middle side. So let's put x as our shortest side. Now, opposite of the shortest side, there's a theorem that basically more or less kind of states that if the smallest angle, the smallest side, will be opposite to the smallest angle of a triangle. So this is going to be 30 degrees right here, and this is going to be 60 degrees. Of course, this is 90 degrees. Okay, so the smallest side is going to be x. The hypotenuse is 2x, okay? And then this middle side is x square root of 3. Okay, so this is the property of a 30, 60, and 90 special right triangle, and I'm not going to go through and just prove this again like I just did with the 45, 45, but this is something you absolutely need to know. So what we're looking at here is we have the short side, and then we have the hypotenuse is double the short side. So let's go back to our figure here, and hopefully you're like, look at this, I got 4 here. This is double that. Oh, interesting. That happens when we have a 30, 60, 90. Let's just check if this side is, the short side times the square root of 3 is this side right here. And that's exactly what you would do in a 30, 60, 90 special right triangle, okay? Because that's important, because now we know the angles of this triangle. We just don't, know that, oh, this is a right triangle. But let's go ahead and verify these sides. Let's suppose you wanted to kind of check and see, well, let me see if this is a right triangle. And let's apply the Pythagorean theorem here to check these sides. Okay, so let's go ahead and just do this work right now. So we'll call this A, we'll call this B, and then we'll call this side C. Of course, the longest side is the hypotenuse, which is always C. And let's plug this in and let's see if this really kind of works out. Okay, so a squared is going to be 4 squared plus b squared, and you can see these sides here. Let me scroll up here. B squared would be 4 square root of 3 squared is equal to 8 squared, and let's simplify it and see if this is true. Okay, so 4 squared is 16. 4 square root of 3 times 4 square root of 3 is going to be 16 times 3. Okay, so again, 4 square root of 3 times 4 square root of 3. We're going to multiply these numbers here. 16 times 16. Square root of 3 times the square root of 3 is square root of 9, or 3. So we have 16 times 3 right here. 8 squared is 64. Okay, so let's go ahead and continue on here. So we have 16 plus 16 times 3, which is 48. And we end up with 64 being equal to 64. This can only happen if this angle right here is 90 degrees or a right triangle. So I could say here is a right triangle that's great, but we still don't know anything about the angles. However, if you know that this is not only a right triangle, but it's a special right triangle, now we know something about these angles, about 30 degrees, 60 degrees, and that's what we need to know in order to solve for this angle right here. All right, so now here is our situation. So we've already concluded, we used a couple different ways to do it, but we had to figure out that this is a right triangle. Now, the reason why the problem is tricky is because this doesn't look like a right triangle. And I kind of exaggerated here a bit. Sometimes you'll see these triangles, maybe a little bit off like this, kind of even exaggerated a bit, or even like parallel lines, they'll kind of do things that are a little bit off, and they're just designed enough to kind of give you doubt because if the figure looks like a right triangle, let's suppose you have a triangle and it looks perfectly right, unless there is a little box in that corner, or this is stated that this is 90 degrees, you cannot assume. Okay, this is another trick that you'll find on tests. They'll make a triangle, for example, look perfectly right, but it's not explicitly stated as being right, and you cannot assume. And then they're going to expect you to assume that it's right. You're going to come up with an answer based upon if the angle was actually 90 degrees, which is going to be wrong. Okay, so you got to be careful with these figures. But in this case, we verified, use the Pythagorean theorem, that we have a 90-degree angle. Okay, so how do we get to this angle right here? Well, if we only have 90 degrees here, we'll have to use sine, cosine, or tangent. Okay, now we could use it, these are trigonometric functions, but why go through all that if we already know that this is a 30, 60, 90 special right triangle? So that's what we're going to do. We're going to make our life a lot easier. So this is really what this figure looks like. Okay, 4 square root of 3, and 8. Now, why is it important to kind of draw a new figure? So if, let's say this was on an exam, you may want to draw yourself a figure that's more accurate, more representative to the actual situation here. Okay, so the reason why I'm doing this is because I'm like, it's clearer to me to where I can identify where the 30 and 60 degrees are at, because this obviously is the 90 degrees right here. So how do we identify where the 30 degrees is and the 60 degrees is? This is a very common place where a lot of math students get this wrong. Okay, so the easiest way to do this is to look for the shortest leg. So here, this is 4. Okay, so find the shortest leg in the triangle and then just go to the angle opposite of it. So this right here is 30 degrees. It's the smallest angle to the smallest leg. Okay, so that's 30 degrees right there. So therefore, this has to be 60 degrees right here, because 60 and 30 is 90, 90 and 90 is 180 degrees. That's how many angles you have in a triangle. All right, so hopefully you see where I'm going with this. This is not going to be that difficult to solve. So this is 60, this is 30. So how do we solve this angle right here? Well, what you need to know is the angle, that straight lines actually have an angle to them. Well, how many degrees, excuse me, are in a straight line? Well, there's 180 degrees in a straight line. So from here to here is 180 degrees. Well, from here to here, if this is 180, and I know from here to here is 60, well, it's pretty easy to figure out what this is right there. That's going to be 180 minus 60, which of course is 120 degrees. Okay, now if you use trigonometry to get one of these angles, that's fine as well. But I can tell you right now, you need to be able to recognize, well, there's a couple big points in this problem. So one, you got to be able to recognize special right triangles, right? This is really, really important stuff. Two, you got to be very careful when you're taking math exams that you can't assume anything more than what's on the figure of the exam, even if it looks like something that doesn't, appear to be right. You just can't make any these assumptions, right? And again, this is something that comes up pretty frequently. And, as the title of this video states, yes, indeed, they actually are trying to trick you. Those bad math teachers tell you, you got people like myself thinking up this stuff and like, boy, why can't you just make this easier? Well, it is what it is. But hopefully this little video helps you out. And if that's the case, don't forget to like and subscribe. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.